now we will do another example, and in this case I will have 3 charges located at the vertices of a triangle, and I want to find the net force on one of these charges. So the figure is this. This is Q2, this is Q1, and this is Q3. Now, this is 5, this is 3, and this is 4 meters. And I want, and Q1 and Q2 and Q3 are given. So Q1 is equal to 2 microcoulombs, Q2 is equal to minus 5 microcoulombs, and Q3 is equal to 10 microcoulombs. What I need to find is, I want to find the force, the net force on Q3, that is on this charge, using unit vector notation. Now, the first thing usually in these questions, the first thing is you, without touching, without starting making any calculations, you use what your knowledge about the forces and so on, and show everything diagrammatically on the graph, and then see what will be, what are the forces acting, and what you expect to get when you add them up. So, the force on Q3 here, I know that F3, the force in 3, is actually F13 plus F23. That is, the force on this charge is due to the force by this charge and plus the force by this charge. So let me show the force by Q1 on Q2. Show it as an arrow or as a vector on the diagram. Now, Q1 and Q2 are both positive, and therefore this charge is this force is repulsive, and so this is the direction of F13. So F13 will be acting in this direction. Now, what about F23? F23 in this case is an attractive force, the force by 2 on 3, and it is directed here. Now, so what I need to find the vector form of F3. That's F3 in vector form. So I need to add up F23 and F13 vectorially. Now, the best tool for this is actually to use unit vector notation, and therefore I have first to find what are F23 is already along the I hat, because you remember this is j hat and this is I hat. These are the unit vectors. So already F23 is already along minus I hat. F13 has a component, the x component, which is along I hat, and a y component, which is along j hat. So this is F13x, this is a vector, and this is F13y. So let me first find the vector F23, then find these vectors, and then add them up. So F23, what is this? F23 is actually equal to magnitude of F23 along minus I hat. And what is the magnitude of F23 in this case? Well, apply Coulomb's law. It is just K multiplied by Q2, Q3 divided by R23 square. Now by R23, the notation is evident. In this case, R23 is this. This is R23, and this distance here is R13, evidently. Okay? And so you just put the minus sign here, and it becomes in this way. Now, it's usually a rule, as we have always emphasized, that you always do your computations, or you write your expressions symbolically and leave the numerical substitution and computation to the last step. So let me keep this way, and then I will not substitute for Q2 and Q3 here, but at the end. Now let me look at F13, this vector. Well, F13 here is the sum of two vectors, this one and this one. This is the x component of F13. And what is this x component? It is just F13, the magnitude, cosine which angle? This angle. Now, this is called theta, if you like. But this theta, I know what is this theta. Why? Because this is a right triangle with, this is the 5, 3, 4 triangle. So this angle here is 37 degrees, because, the sine of this is 0.6. So this is also 37 degrees. Okay? So cosine 37 degrees. Now, along I hat. It is along I hat. I don't put a minus sign because it's pointing in the positive I hat. It's along positive x direction. The same applies for this. This is also pointing along the positive y direction. So it is F13 sine 37 degrees along j hat. Now, what is F13? This is the modulus of the force between 1 and 3, charges 1 and 3, and this is again K Q1 Q3 over R13 square cosine 37 degrees I hat plus again K Q1 Q3 as absolute value R13 square sine 37 degrees j hat. So I have F13, I have F23. Now I can add them. I know I have them in terms of components. So F3 in this case, which is just F13 plus F23, I add the x components, I add the y components. F23 has only x component, so it doesn't have y component. So in this case, this will be, you can take k as a common factor all the way, and you will have the x component here. It will be Q1 Q3 over R13 square minus Q2 Q3 over R23 square. This is along I hat, plus you will have Q1 Q3 over R13 square. I have here to add something here. Here I have cosine 37 degrees, and this will be sine 37 degrees. This is along j hat. Now what remains is to enumerate. You substitute k equals 10 to 9 times 10 to the power 9. Q1 and Q3, you have their values. You don't forget the micro, which is 10 to minus 6. So I will have 10 to minus 12 coming here. Cosine 37 and sine 37, I know. R13 and R23 are also known. They are given in meters. So if you do the calculations, according to my calculation, what I have got in this case is the following. This is equal to 2.24 times 10 to the power minus 2 I hat plus 4.32 times 10 to the power minus 3 j hat, of course, in newtons. Okay, so this is the force on F3, the net force on the third charge Q3 due to these forces. And if you want to find what is the magnitude of this force, it is just, 2.24 times 10 to the power minus 2 square plus 4.32 times 10 to the power minus 3 square, and you put this all under square root and this, evaluate this expression, and you get the net for the magnitude of the net force on the charge Q3. So this is how we do calculations using when we want to apply Ampere Coulomb's law. We do not use the vector form which has r hat 1, 2, or and so on. You just make the calculations. You use your vectors. You show your vectors, and then you try to express the forces by finding first the magnitudes and then express the forces in terms of the magnitudes and unit vectors. And this is how you handle these.